In this problem, we have a 5-pound collar. This collar is released from rest at point A. It's connected to a spring. The spring has a spring constant of 4 pounds per foot. The foot gets clipped off. So this is the state 1. And then it travels along this frictionless guide, which means that we do not need to consider friction. And then it will travel until it hits point B, still connected to this spring. This is my state 2. And we need to determine the speed of this collar when it is about to strike point B. Eventually, we know that it will be stopped, but what is its speed before it strikes point B? The spring has unstretched length of 0.5 foot. So again, this is a problem where we only have conservative forces doing work. We only have weight and spring force doing work. Friction is not considered. So again, we can use conservation of energy to solve this problem. So we will have T1 plus U1. Total U1 include the gravitational potential energy and elastic potential energy, and that equals to T2 plus U2 gravitational plus U2 elastic. So initially, the collar is released from rest. This is a 0. And then for gravitational potential energy, we need to choose a datum. It's up to you, but I'm going to choose this as my datum. Therefore, U1G equals to weight, 5 pounds, times the position above the datum. In this case, this entire distance right here, that's 1 foot plus another 1.5, so 2.5 feet. And then U1E equals to 1/2 K S1 squared. In this case, that equals to 1/2 times 4 times S1 is the total length of the spring at state 1, which is 2.5 foot, minus 0.5. Don't forget, the original unstretched length of the spring is 0.5 squared. So when you're calculating the potential energy of the spring, this S right here is always the displacement from the original length of the spring. And then on the right-hand side, T2 equals to what we need to solve for, 1/2 mv squared, which equals to 1/2 times m is 5 over 32.2. 5 is weight. 32.2 is the gravitational acceleration in the pound-foot system. So 5 divided by 32.2, that gives you the mass in slug in the pound-foot unit system. Multiplied by v squared, and v is what we need to solve for. U2G is 0 because we chose point B to be our datum. U2E equals to 1/2 K S2 squared, which is 1/2 times 4 times, this is 1 foot, therefore 1 minus 0.5 squared. And now we're ready to set up our equation. On the left-hand side, we have 5 times 2.5 plus 1/2 times 4 times 2.5 minus 0.5 squared. On the right-hand side, we have 1/2 times 5 over 32.2 v squared plus 1/2 times 4 times 1 minus 0.5 squared. In this equation, we only have one unknown, which is v, so we can solve for v to be 16.0 in the unit of foot per second.